Well, there's been a breakthrough in ancient aliens, ancient advanced civilizations, ancient advanced technology, as indicated by massive megalithic structures all around the world that we can't lift into place even today. It's ridiculous. Like the pyramid, if they built that using, slaves and ropes and whips and shit like that, they'd still be building it today. 2.3 million blocks and all this sort of thing. Very industrial purpose, all that sort of stuff. Obviously, we can dismiss ancient aliens because the technology was from an advanced civilization, and you know what? Turns out the technology is not that breakthrough, as we'll find out here. This guy here posted this 3 days ago. Came up in my feed. I didn't know I was subscribed to him. It's been a while since I've gone down this rabbit hole, because normally I'm arguing with someone on the internet over the Ukraine war, or how Trump backflipped and is completely owned by Zionists and all that sort of stuff. But anyway, it's great to get back into it. The nubs are finally solved. Yes, they are. This is not some clickbait. This is real. Let's get into it. So he starts off and he goes, oh yeah, these nubs, what's going on there? Do you realise if this was carved with bronze chisels, I love saying bronze chisels because it's the most ridiculous mainstream. The whole reason why people went down this rabbit hole in the first place is because the mainstream archaeology is lying. And it's very obvious that they're lying. Bronze chisels on granite is so ridiculous that I can't even say it with a straight face. See these knobs, if this was done by alright, laugh along with bronze chisels. Sorry. You'd have to cut 3 or 4 inches into the stone before you started carving your flat surface. So these nubs are what's called embossed. I think that's a word. Sticking out, right? Which means they're a drain. They look like a drain hole. They've even got discoloration, like there's some extra heavy mineralisation different from the main structure. Now, so he's saying, yeah, these are drain holes, and he'll go into it. And you look at this; these are bulging, which means they were like leather bags or something to hold all the moisture in. Now, I dismissed geopolymer originally because I thought there's no way this is concrete. This is stone, and well, let's get into that further, and we'll see why it's actually non-water-based geopolymer. Very, very interesting. Well, it's kind of water-based, but no, it's silica-based. It's silica gel, basically. Very, we'll get into it. It's very easily made. Well, not really. You'd need an advanced civilization to make it, but not that advanced. Right? Anyway, so these blocks are very consistent, probably Roman, I don't know. But these rotated stones, so like they were, this was on the bottom to stop the sand from falling out. So there's like a filter. Same here. These were facing down and they were lifted in position from a mould, very consistent sized, close fitting. It's like we pour concrete today. We do hollow blocks because we're cheapskates and we like to save material and make them lighter. Then we pour them with Rio and concrete. Anyway, this one's another one. These were poured into moulds facing down. The filter is here, and then it was hoisted in position. Now these nubs. Imagine if that was carved with bronze chisels from a solid piece of stone. Sorry. Or a dolerite, is it? Dolerite balls. Dolerite balls. I don't know how you carve square edges and especially internal corners with a dolerite ball. Oh God. Anyway, it's mainstream archaeology. It's hilarious. Anyway, we got these nubs. So they started off with a block way out this depth here and carved a foot into the rock before coming up with a flat surface with bronze chisel. No, they didn't do it. That's a mould, that's a drain. So how the hell do you pour stone? Not concrete. Concrete, we have water in the mix and dries out. How do you pour stone? Well, we'll get right into it, won't we? Here we go. Here's another example. Here's how they would have. Why? Look at this. You what? See that corner there? The block comes around the goddamn corner. Don't tell me that you started out here and then carved a flat surface there, and then decided to carve with bronze chisels into the rock another 3 or 4 inches before you start your flat surface. Are you serious? Anyway, so moving right along, as I mentioned, the ancients, he's done an AI caveman mixing cement. He says it was with a deadpan look on his face. He's dead serious too. It's awesome. So let's get into how they make this stuff. Right, I've closed the video, the volume here, and what have we got? We've got this area that is full of, come on, get on with it. This looks like a quarry where they've quarried some silica material. Remember that, I don't know if I showed it yet. No, I haven't showed it yet. Somewhere along here. Here it is. You need this stuff. This is basically water glass, a geopolymer. It's silica, and when you mix it with water, you end up with a gel. And that's what you drop your sand into and drain it out the bottom and let it set, and it's you got concrete. Well, stone concrete, indistinguishable from concrete stone. You know why? Because the quartz in the rock is what holds your granite together. You know, ever heard of quartz? Granite has quartz in it, right? That's the glue. Right. Okay, so there you go. Right, anyway, we're with the caveman. He reckons they've extracted silica here. I don't know why they don't just shovel that stuff and pour it in some sort of vat full of, we'll get onto it, how to get the silica out very soon. You can get it out with this stuff, but this is alien blood, like in the movie Alien. It melts through everything, you know, super corrosive. So he's saying that they didn't use this because their technology was not that advanced. And the only thing that can contain this is plastic. Otherwise it'll just eat through everything. Metal, glass, rock, everything. Just like alien blood. So let's call this stuff alien blood and move along. So here's our water glass geopolymer. So how do we make that stuff? Well, let's get into it. Oh, this is just some guy I've been arguing with on the internet. I've really pissed him off. He's blocked me twice. This will be the 3rd time he's blocked me. He's getting really triggered, arguing over the war in Ukraine. Move along. Okay, now this guy here, way back at the start here, right? He's referencing this guy, Marcel Foti, who's the guy who's making, in this latest video, only 2 weeks old, a granite, well, out of sand, it can be anything. He's made it out of 4 different materials, right? And he's just, you can see the different flavours there in the background, different materials. Obviously we saw a quarry there with pink granite material there. And to make this water glass that you just drop sand into and then drain out the bottom, you need this material here called caustic soda, Drano. Well, they didn't have Drano back in the ancient times, so then here's the equivalent of the silica. He's got one of those bags from, you know, packaging, dries out. But where did they get it in the ancient times? Well, he mentions volcanic ash. So you're making sodium hydroxide. That's the caustic soda that we saw here. Where is it? Yeah, there. That's the stuff. That's the secret ingredient to make. Let's not get lost here. To make that, you need that, and to get that in ancient times, you needed volcanic ash. Where does it say volcanic ash? I'm sure I had one of these things open with volcanic. Wait, bear with me. That tab is in the wrong place. It should be over here. Oh, there it is. So you need volcanic ash. Heating a mixture of processed volcanic ash. And so, that's how to make water glass. Sorry, that's it. You need. Okay, you can use volcanic ash to make your water glass. There's your silicon source, because back in the old days they never had these in their packaging, so they used volcanic ash. Where the hell is it? There it is. Now, that means we need the other ingredient to make water glass, sodium hydroxide or caustic soda. Now, as you can see, that requires some level of advanced civilization, but not something that is super advanced like today's technology. They've had caustic soda for, I don't know, a few hundred years now, I guess. Turns out you make it from salt water, very, very readily available. The only thing is, industrial electrolysis is usually how they make it. I'm sure there's other ways of making it. How else can you make it? Let's have a look. But since electrolysis has been mentioned, let's not forget that the bag, this brings to mind the Baghdad battery. You know, it's not like you can plug your hairdryer into this thing or turn on a light globe, which is what they reckon. They reckon they invented the filament lamp. Honestly, it's a lot easier to make caustic soda than it is to make a glass bulb with a filament in it filled with sealed gases. I think argon is in there or something to stop the filament exploding as it heats up. So I would say that these could be used to make water glass. And just to show you that it's not the end of the world making this stuff, apparently you can make it from rice husks. Rice husks are incinerated to 600 to 700 degrees. You can extract it, as we said, from sand or quartz using hydrochloric acid, a different type of acid this time. So basically all they would have had to make is some sort of alkaline or acid back in the ancient times to get this stuff. So let's move along and make some water glass out of it. So we've got our ingredients here, this, that, and he's mixed a bit of water in there too. It's not completely water free. And he heats it up on a Bunsen burner, because where would we be without our Bunsen burners? And he goes to silica, blah, 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 and there's our gel right here. Oh, one other thing, you got to mix 2% lime. Slate lime is what he's adding, 2%. It's a catalyst in the mix. You can't just turn the quartz into, the silica gel into quartz without the slate lime. Only 2%. That's why it comes up like granite, because these ingredients are just like a glue. It's 99% sand, granite, material, rock. Only a little bit is this stuff. 2%, what was it again? Slate lime. So you drop it in there, this sand in this silica gel, and you must keep it below the gel level. Otherwise it's going to have bubbles in it, and he's poking around with a spoon. You just need a mixer. Sets there on the bottom. Now he's cutting his hole to let the silica gel drop out, and is reusable. You can catch that and reuse it for another mix. And if you don't do that, it won't set. It'll stay piss weak, and it's game over. So you got to have a nub to let it out. It drips slowly. It probably takes a day or two, I guess. But there it is, dripping out into this beaker for reuse. These ones were obviously poured in place with the nubs already on the bottom. I don't think they had bronze chisels to knock them off, so they left them there. These ones, you can, if you get to it early enough as it's setting, you could possibly remove the bagging and it would hold its form, and then at that point you could possibly knock it off. Here's an example of a stone that was being cut while it was still soft, like clay, literally like clay or Play-Doh. And as you can see, they went off kilter. They gave up on that one, so it ended up in the junk heap. What else we got here? All this sort of weird stuff, right? Slice, and dice. And here is Pierre, I think his name was. Anyway, core number 7, if I recall, has a rate of cutting with a tube drill at a phenomenal speed. It had to be clay at the time. Here it is. Look at this. Something like this. Just some ridiculous... Petrie, not Pierre. Petrie's granite drill core number 7. Phenomenal rate of penetration. And also there's a lot of holes around Egypt. Similar. And cores. Here's a hole with the same penetration rate on the sides. So there you are. They made it using water glass, and there's our battery. That's my theory anyway. There's a lot of ways to get the necessary ingredients, and it kind of somewhat explains the scoop marks here at Aswan Quarry. As you can see, there's probably been some corrosive action going there on the stone, and then they've chipped it away and poured another one and carved into the rock with, and then there we got their famous scoop marks as a result. Obviously they'd be little puddles that they corrode the surface of it, as I just said, and then clean it out and have another go. And what does remain, however, is the question as to if they can just pour this bloody obelix Did I say that right? Obelisks. Why would you carve one out and then ship it on a boat, allegedly? 1,200 tons, this thing. It's 1,000 at least. On a boat 600 miles downstream to Egypt, where you stick it up. I don't know why you would, unless there was something about the original stone that the geopolymer form of stone was not inadequate for. I don't know, maybe resonant technology. But it does keep the door open to mystery. Even though the nubs have been solved, I'm sorry, but this is just, everything just matches up perfectly. Absolutely perfectly. Like why these bulge out. They weren't as fussy as the Egyptians. They didn't rip off the mould and render it flat before it's set. They said, she'll be right, mate. And it's been absolutely proven. You can go and make it yourself. Marcel Foggy, go and check him out and get the ingredients and go and make yourself some megalithic structures. It's all there. Problem solved. There you go. Well, we better go to work now. I know it's a Sunday, but I'm busy. This is my procrastination. At least it's not porn. See you later.